What are we doing today? Classwork, answer keys, but video form. So let's go through the first one. Can you light a bulb? Now we're using the PhET simulator, and the first thing it asks for is using a wire, battery, and bulb. Can you light a bulb? And what is really important about this, the most important thing probably for circuits, a couple rules for us for any and all circuit. The first is that our circuit needs some sort of source of energy. So this is a source of voltage, power source, right? I'm also then going to need something to use the energy as well. So number one, I need something to supply the energy, and then I need something also to use the energy. Now the third thing we need is we need this circuit to be connected in terms of a loop from the power source, from the voltage supply, from the energy source back to the energy source. So if you see, if I connect it with a wire, this isn't good enough because I don't have a complete path for my electrons back to the power source. But then if I do this, boom, what am I getting? I'm getting my electrons gaining energy right here in the power supply. So they're gaining energy, right, heading down this wire, losing energy in this light bulb, and then heading back, please sir, can I have some more, and getting more energy and completing that. So if we don't have a power source, right, so something to supply the energy, something to take the energy, and then a complete path, we won't have a functioning circuit. Now, if we talk about the second part of the question, the second part of the question is asking to meet some strict guidelines. So I already have this open another tab. Now, in terms of what we want, I want the first bulb to basically control everything. So if that bulb were to burn out or that bulb were to break, right, that everything else stops. But I want that the other bulbs can go on and off, no big deal. So what we'll do is we'll set up the battery here. I'm going to rotate it a little bit to make this as clean as possible. And the first thing I'm going to do is I'm going to connect a wire here, boom, boom, like this. I want all of my electrons going through this first bulb, because if something goes wrong with this first bulb, I want them all to stop, right? That's what we want here. The next move I'm going to make now is right here after this switch, I'm actually going to put one wire to this bulb and a second wire here to the other bulb. So what this is going to do is this is going to give the electrons two separate paths, two different ways they could go. So if this first light bulb here, if light bulb B was burnt out and this path was no longer a real path, the electrons could still take this path. But now the only way to make this work is I'm actually going to have to reconnect these paths together. And I'm using more wires than I would need to, just so you can sort of see it as neatly and as cleanly as possible. And then I'm going to run this back here. And ready? Ta-da! Ta-da! Nothing happened. It's because the switches are open. If we close these switches, yay, the lights are on. Now notice how the brightnesses are different? That's interesting. Maybe that's something more for another time, but still good. So let's check the first requirement. First requirement is that if bulb A goes off, everything goes off. Whoop. And if we think about what's going on here, yes, I still have a power supply. Yes, I still have stuff to use the energy. But what I no longer have is I no longer have a path from my energy supply back to my energy supply. So you can see my circuit's broken. Great. Now, if I were to whoop whoop, whoa. You see, I still have these other ones on because why? The electrons here at this spot, so when you have any spot where wires meet, we call it a junction. So at this junction here, the electrons don't have to go down this path because there isn't a path for them to go. You can see how it's not connected there. So they're just going to take this other path here. Let's just check to make sure. So that one's good. Oof. Also, that one's good. So you see what we've done here is we've met the requirements of that problem and of that question. This is a little bit complicated of a circuit, but this is certainly the simplest way to get this done. We'll use some more circuit words soon. On to our next homework, nightly feline questions. Nightly feline? Anyone get the joke? All right, we'll see. We want to know if we look at an original circuit. And what's nice about this is I have this, and I can actually just sort of like leave this off to the side to make comparisons. So that's what I'm going to do. And this is 10, 9, great. And the first thing it's going to ask me to do is if we add more batteries, what's going to happen to the brightness? So instead of one battery, what if instead I had two batteries? Well, let's see. Let's get our bulb. Okay, that's just rotated it. We're getting here. Boom. Whoa. You can pretty easily see that this is pretty much brighter. Now, if we wanted to, we could add another battery and see if does that form the same. Oh, even brighter. Now, why would this make any sense? Well, these batteries we said are what's supplying the energy. So if I have my electrons coming here, can I have some more, sir? And then, oh, can I have some more? Can I have some? So they're gaining more and more energy. So I think it should logically make sense to us that if we have more batteries here, right, connected in this manner, not in another way, but connected like this, we're getting the amount of energy in the system to be more because there's more things supplying the energy. Now, the next thing we're asked is what if we add a resistor anywhere we want in the circuit? So, and this is, again, we're going to do this, and what I'm going to do is, let me rotate that back. It's annoying me. I'm going to put the resistor right next to the bulb. It does not matter. But now, I see, looking at these, I think it's pretty clear that this bulb is dimmer. Right, but now why would that make sense? Each of these systems, right, if you think about them as that, each of these circuits have the same amount of total energy because they have the exact same battery, and you can see 9 volts and also 9 volts. But this second system, it has a light bulb and a resistor, 2 things using energy. Think back to the other conservation of energy problems we had, right? If I have 2 things that are using energy as opposed to just 1, well, the 1 is going to be more than the pieces, but together they'll still be the same. So total, this is going to be a total here of 9 volts being used, right? But I'm using some in the bulb and then some in the resistor. So I think this would make sense. And the more things I would add here in this style connection, I'm going to get this bulb to be dimmer and dimmer and dimmer. Then it's saying, hey, do you know that you can change stuff? So click on the bulb and increase the resistance. As you increase R, what's going on? So now we want to go back to our original, right? So we see that these are the same. And if I click on this, I can now start to increase the resistance. Oh, whoa. A little fire there for a minute. So as it gets bigger and bigger and bigger, you can see that the brightness is decreasing. Now, does that make sense? Well, as we increase resistance, we're making it more difficult, more challenging for the electrons actually to make their way through the bulb. So, with each of these systems, we still have the same amount of total energy, the same 9 volts, but I've made this significantly more difficult, so we get less output, less brightness. And I think, again, logically, we've made this harder, right? So we're getting less of that sort of output in terms of light. And then the last thing it's asking us here is can you light it on fire? Well, you just saw a little trick there, but another way to do this is the following. So if we have a circuit, so we said we need something to supply energy, something to take energy, and then a complete loop. If I have something to supply the energy, but I do not have something to take the energy, we will get fire, also known as a short circuit. And you can see it actually times this other one out because it's saying like, yo, bro, chill. But if we think about what's going on here, right, these electrons are coming into the battery, right, the energy supply, and they're gaining energy. And then they go into the wire, and they don't lose anything. They go into the wire, and they don't lose anything. Now they're back at the battery. And the electrons are going to say, please, sir, can I have some more? And they're going to gain more energy. Right, and they're going to go through the wire, and then gain more energy, and then gain more energy, and gain, and gain, and gain. And they're never going to lose that energy. And because they're not losing that energy, right, this is what's going to cause a lot of heat to build up. And this is what we refer to as a short circuit. Now, this is a total short circuit. There are other ways to just short pieces of a circuit, but that's a little bit... That's a conversation for another time. But this would be defined as a short circuit because I have when the electrons get back to this side of the battery, they still have energy. Okay, they still have a voltage. They should use all of their energy by the time they get around to there. So that's it for the questions. I hope this helped. I hope that this made sense to you. And if not, obviously, as always, email me. But I will see you all real soon for class. Until next time, thanks for watching.